Hello everyone. Let's take a look at our next problem. There's a game with two players, A and B, who take turns to roll a die and have to roll a 6 to win. What is the probability of person A winning? Okay, so my first thought is that this is similar to a question we've seen before where players are taking turns eating chilies and the game ends the first time one of the players eats a hot chili. It was basically a version of Russian roulette. So the difference here is that this game doesn't have an upper bound on how many turns can be played. I'm probably going to want to write down a recursive expression for that relates the probability of A and the probability of player A winning versus the probability of player B winning. So I mean, this of course, it depends on who goes first. The player who goes first has a higher probability of winning because, in some sense, they could roll a 6 on their first turn. So let me just think about the best way to parameterize things that I want to write down. So what I think I'm going to do is I'm going to write down the probability, or I'm going to write down an expression which represents the probability that player A wins on their first turn. Well, that's just 1 and 6, isn't it? Let me think. Okay, hold on. Let's say PA is the probability, and we're going to suppose that player A goes first. So the probability P of A is going to be the probability that A wins outright. Okay, so it's pretty clear that PA is going to be equal to 1 over 6 plus 5 over 6 times, in fact, I think it's going to be times PA, right? So if we imagine the case that the first roll is not a 6, if the first roll is not a 6, then it becomes player B's turn. And on player B's first turn, given that player B has a first turn, their probability of winning is going to be the same as the probability of A winning before the game even begins, right? We're assuming that all the dice rolls are independent and so on. But yeah, so if PA is the probability that player A wins before anyone has rolled a die, if it is not a 6, then now the probability that player B wins is the probability that player A was going to win before that. So this should just be P of A. And now we just have to solve for PA, right? So I have PA times 1 minus 5 over 6 is equal to what am I doing wrong here? Oh. Yeah. Okay, so what has to go here? I realize what my mistake is now. So PA is the probability that player A wins unconditionally, right? Before anything has even happened. That happens immediately with a probability of 1 over 6. But with a probability of 5 over 6, we go to the situation where player B goes first. Now, if it's player B's turn, their first turn, their probability of winning is just whatever number this is. But if that happens, then player A loses. So what I need to put here is 1 minus PA, because condition on player A not winning on their first turn, the probability of them winning is 1 minus the probability of player B winning. But on player B's first turn, the probability of them winning is just PA, which is the unconditional probability that player A wins. Okay, so now if we solve for PA, 1 over 6 plus 5 over 6 minus 5 over 6 PA. So what is this? 11 over 6 PA is equal to 1. So PA is equal to 6 over 11. Okay, so I mean, this number is clearly greater than a half, as you would expect. The probability that the first player wins should be greater than a half. It's certainly not a fair game. Is there any other sanity check that we could do on this? What we could do as a sanity check is imagine it's not a 6-sided die, but an n-sided die. And you have to roll a 1 to win. Then the relation that we would have would be 1 out of n plus n minus 1 over n times 1 minus PA. So what do I have here? PA is equal to 1 over n plus n minus 1 over n minus n minus 1 over n PA. Okay, so for an n-sided die, and you win conditional. You win if you roll one particular number between 1 and n. The probability that the first player wins is this expression, which depends on the number of sides of the die. And the thing that I was looking for here is I wanted to see what happens as n gets very large. And the probability that the first player wins, in this case, converges to a half, which you would expect, right? Like if you have a 10 million sided die and you're alternating taking turns, and the first player to roll a 1 wins. Well, if you don't win, you're probably not going to win on the first roll, right? And it's it's much more fair game when there's a huge number of possible outcomes. You could do the opposite. You could take the smallest. Think of flipping a coin rather than rolling a die, and the first player to flip a head wins. You certainly want to be the first player to go because you have a 50% chance of winning immediately. Yeah, so the sanity check here was checking the two extreme cases on the number of sides in the die. Things seem to work out intuitively, and this would be numerically, this would be a nice thing to verify by a simulation. But I'm pretty sure about this one, so I'm not going to go ahead and do that. Thanks for watching.